The outboard engine revolutionized recreational and commercial boating with its portability, ease of use, and versatility. Its development, spanning over a century, reflects engineering breakthroughs, market demands, and environmental pressures. In the late 1800s, boats relied on sails, oars, or heavy inboard engines, which were expensive and impractical for small vessels. The advent of internal combustion engines sparked interest in portable marine propulsion. Early experiments like those by the American Motors Company in 1896 adapted small gasoline engines for boats, but these lacked the integrated design of true outboards. In 1905, American engineer Cameron B. Waterman patented the first commercially successful outboard motor. Inspired by a motorcycle engine, he began designing in 1903 and created a two-stroke gasoline-powered unit, producing about 2 horsepower and weighing 40 pounds. It combined an engine, propeller, drive shaft, and rudder, making it detachable and ideal for small boats. By 1910, the Waterman Marine Motor Company sold thousands of units to fishermen and recreational boaters, laying the groundwork for the industry.
Here she wants to go.
In 1909, Norwegian-American Ole Evinrude introduced his own outboard motor, often credited with popularizing the technology. While boating on a Wisconsin lake in 1907, Evinrude, frustrated by rowing to fetch ice cream for his future wife, Bess, envisioned a lightweight, reliable engine. His 1.5 horsepower, single-cylinder, two-stroke motor, made of steel and brass, weighed 62 pounds. Its simplicity and affordability drove commercial success. Launched in 1910, the Evinrude Company sold over 1,000 units in its first year, with Bess managing marketing and operations, establishing the brand as a market leader.
Now, look, we can sell these motors for $42.50 a piece. I figured out time and materials, and that's what we've got to charge for them.
Oh, that's a lot of money, Bess.
Ole, I think you'd give them away. You have a wife and son to support now, remember?
Yes. I think I better stop making these things and work on something that will bring in enough to keep the shop going. I have to build up a business.
Ole, now you look at me. Ole, sometimes I wonder about you. Well, this can be your business. Make these motors, build them better. Look, Ole, I made up this advertisement, and I think we ought to put it in the newspapers, and I think we ought to put it in that magazine about boats. Now, take a look at this.
You made this, huh?
I made it up. Come on.
Don't row. Throw the oars away. Use an Evinrude motor.
Bess was your business manager, signing herself B. Evinrude, so your customers wouldn't know they were dealing with a woman. In 1911, the Evinrude Company moved into a new plant, hired 100 shop hands, and produced more than 2,000 motors. Paperwork piled up on Bess even though she hired 6 assistants. 1912, your plant shipped 4,650 motors. In 1913, 9,412 motors.
Evinrude's early success was bolstered by continuous improvements in design and manufacturing. After selling his company in 1913, Ole Evinrude returned in 1921 to form the Evinrude Light Outboard Motor Company, introducing models like the 1922 Evinrude Lightweight, which reduced weight to under 50 pounds while increasing power to 2 horsepower. This model incorporated a novel folding tiller for easier storage, appealing to recreational boaters. The company's focus on durability and user-friendly features, such as simplified maintenance, solidified its reputation among fishermen and small boat owners in the Midwest and beyond.
In 1921, you were ready with the motor that changed the world's thinking about outboards. The first opposed twin-cylinder motor made of aluminum, machined so precisely that it set a new standard for the industry. You couldn't legally use your old company name then, so you called it the Evinrude Light Twin Outboard. The initials spelled ELTO. They also spelled a second success for you and Bess.
An outboard engine is a self-contained propulsion system typically mounted on a boat's transom, integrating several key components. The powerhead, housing a two-stroke or four-stroke internal combustion engine, or electric motor in modern designs, generates power, typically ranging from 2 to over 600 horsepower. The midsection or drive shaft housing contains the drive shaft, which transfers power from the engine to the lower unit. The lower unit, or gear case, includes the gearbox, propeller, and skeg, converting engine power into thrust while enabling steering via a tiller or remote system. There are now two types of engines available, two-stroke and four-stroke. These names are derived from the number of strokes that the pistons take to complete a cycle. For example, a four-stroke engine takes 4 piston movements to complete its engine cycle. The piston lowers for the intake stroke, drawing in the air and fuel mixture, raises for the compression stroke. The air-fuel mixture is ignited for the power stroke, forcing the piston down, and finally raised for the exhaust stroke, forcing the exhaust out of the engine. The cycle then repeats over and over, turning the crankshaft. A two-stroke engine is designed to accomplish its complete cycle in just 2 strokes. During its power stroke, the ignited air-fuel charge forces the piston down until it reaches an opening on the side of the cylinder called the exhaust port. As the piston continues down, it pressurizes the air and fuel mixture under the piston that was drawn into the crankcase during the previous compression stroke. An intake transfer port is exposed, allowing the pressurized air and fuel into the cylinder. Finally, as the crankshaft continues to turn, the piston rises, closing off the intake and exhaust ports and compressing the air-fuel charge inside the cylinder. The rising piston also sucks the next air-fuel charge into the crankcase from the carburetors. The compressed charge is ignited by the spark plug, repeating the cycle. The biggest advantages of two-stroke engines are lightweight and simplicity in parts. The engine itself weighs significantly less than a four-stroke of equal power output, and there are anywhere from 30% to 50% fewer moving parts in a two-stroke engine compared to a four-stroke. It is also much easier to clear out a two-stroke engine that has been swamped with water. The biggest disadvantages are increased fuel consumption and elevated hydrocarbon emissions. Because a two-stroke has its intake and exhaust open at the same time, some of the fresh air fuel charge passes through the cylinder and out the exhaust port without ever being burned. Because of this and other factors, two-stroke engines have higher unburned hydrocarbon output in their exhaust than comparable four-strokes. On the one end, we have small, portable outboard motors. These are lightweight, easy to handle, and perfect for smaller boats. These motors are often single-cylinder models, but can also be designed as small multi-cylinder engines. On the other end, we have larger, more powerful outboard motors for bigger boats and more demanding conditions. These engines provide significant power and ensure that boats can maneuver easily in rough waters and challenging situations. Nowadays, they are typically designed as four-stroke engines and have multiple cylinders. The cylinders can be arranged in various configurations, including inline, V, and boxer engines. The number of cylinders and the arrangement have a significant impact on the power, smoothness, and weight of the engine. Let us now have a look at the main components of an outboard motor. The cowl is the outer cover of the engine, designed to protect it from water and debris. It also reduces engine noise and contributes to the engine's overall aesthetic. The engine block is the core part where combustion occurs, generating the power to move the boat. It houses the cylinders, pistons, and other critical internal components. The auxiliary systems include systems for fuel delivery, cooling, lubrication, air supply, and electrical operations, ensuring the engine runs smoothly and efficiently. The drivetrain in an outboard engine is essentially the system that transmits power from the engine to the propeller, enabling the boat to move through water. It consists of several key components, each playing a crucial role in the smooth operation of the boat. The drive shaft is a long shaft that connects the engine to the gearbox and the propeller. Think of it as a long stick that transmits the engine's power all the way down to the propeller. The gearbox allows for the change of rotational direction and speed, thereby controlling the forward and backward movement of the boat. In the neutral position, the connection between the engine and the propeller is interrupted, so no movement occurs. In the animation, we see a schematic representation of the gearbox of an outboard motor. The blue shaft is the drive shaft, at the lower end of which there is a pinion, blue. This pinion drives two gears, one for forward, green, and one for reverse, red. Both gears for both directions of travel always rotate when the engine is running. Right now, the engine is in neutral position, so there is no movement of the propeller shaft and the propeller. If we move the gear lever to the forward position, the dogs of the clutch, magenta, engage in the grooves of the gear for forward travel. The clutch now rotates with the green gear. It is connected to the propeller shaft, which is now also set in a forward rotational motion. In reverse, the process occurs correspondingly with the reverse gear, red. When switching from forward to reverse, it is important to make sure that the gearbox remains briefly in the neutral position between the two gears. This is colloquially referred to as the memorial second for the gearbox. If we were to switch directly from forward to reverse gear or vice versa, the gearbox could be damaged by the acting torque. Attached at the end of the drive shaft, the propeller is the final piece of the puzzle. When it spins, it pushes water backward, which in turn propels the boat forward. The design of the propeller, including its size and the angle of its blades, greatly affects the boat's performance. The 1910s and 1920s saw rapid advancements. By the 1920s, outboards reached 10 horsepower, with multi-cylinder designs improving performance. Johnson Motor Company, founded in 1921, introduced the 1926 Big Twin, a 6-horsepower model popular for larger boats. Early outboards required hand cranking and tiller steering, but the 1920s brought electric starters, though costly, and the 1930s saw early remote steering systems. By 1929, over 30,000 outboards were sold annually in the United States, driven by demand for fishing, racing, and leisure. The Great Depression slowed growth, but new players like Mercury Marine, founded in 1939 by Carl Kiekhaefer, emerged with reliable models like the 1940 Wizard series. In the 1930s, Evinrude merged with Johnson Motor Company and other manufacturers to form the Outboard Marine Corporation, OMC, a powerhouse in the industry. Under OMC, Evinrude introduced the 1933 folding shaft model, which allowed the motor to tilt upward when striking underwater obstacles, preventing damage. This innovation became a standard feature in outboard design. Evinrude also pioneered corrosion-resistant materials, such as bronze propellers, and improved aluminum alloys, enhancing longevity in harsh marine environments.
Your first motor couldn't have pulled all that weight, Ole, but its basic design is still followed by the industry today. Then came the 1921 Alto, the first successful twin and the first made extensively of aluminum. The 1928 Quad, the first 4-cylinder outboard and the first to pass the 40-mile-an-hour mark. The 1930 Fold Light, the first folding outboard. The 1931 460, over 70 miles an hour in time trial runs. The 1934 Light 4 Imperial, first to wear a protective hood.
Post-World War II prosperity fueled a golden age for outboards. In the 1950s, engines like Evinrude's 25 horsepower Big Twin and Mercury's 1957 Mark 75, delivering 60 horsepower, powered faster boats and enabled water skiing. In 1964, Honda introduced the GB30, the first four-stroke outboard, offering smoother operation and better fuel efficiency than two-stroke models, though heavier and pricier. Electric starters became more common, and ignition systems evolved from magnetos to electronic setups, improving reliability. Remote throttle and steering controls made outboards suitable for larger vessels. Outboard racing, sponsored by brands like Mercury with its Thunderbolt series, drove high-performance innovations that reached consumer markets. By the 1960s, companies like Yamaha and Suzuki joined the competition, expanding the market. Evinrude's contributions during the mid-20th century included significant advancements in two-stroke technology. In 1958, the company introduced the Starflight series, which featured a 50-horsepower V4 engine, one of the most powerful outboards of its time. The Starflight incorporated a sleek design and improved fuel delivery systems, setting a benchmark for performance and reliability. Evinrude's focus on power-to-weight ratio made these engines popular for competitive boating and recreational use, including water skiing and sport fishing. The brand's racing heritage also grew, with Evinrude-powered boats winning numerous championships, reinforcing its reputation for high-performance engineering.
That's how it is today, Ole. We wind up the motor and go wherever the water goes. It's a new way of life, a water way of life. But outboard motoring sowed its wild oats before it settled down. There was a period of rip and roar, of speed and more speed.
The 1970s introduced environmental and economic challenges. Two-stroke engines, which burned an oil-gasoline mixture, were noisy and emitted high levels of hydrocarbons. The U.S. Environmental Protection Agency's emissions standards in the 1990s forced innovation. Evinrude and Mercury developed low-emission two-stroke technologies like direct fuel injection, DFI. Four-stroke engines gained traction for their cleaner, quieter operation. Yamaha's F-Series launched in 1984, and Honda's BF Series set new standards for fuel economy and emissions compliance.
The allotted time was running short. Time for only a few more attempts at reaching 200 miles per hour. As the average speeds increased, excitement grew along the banks. Two-way average speed, 170.655, and a new world's record. Two-way average speed, 174.855, and another new world's record, but not the record they wanted. The final run of the day, and the assault on the record. Two-way average speed, 176.556 miles per hour, and still another new world's outboard speed record.
Mercury Marine's introduction of the 2.4 EFI Bridgeport in the 1980s revolutionized outboard motor technology as the first to feature electronic fuel injection, EFI. This innovation allowed for precise fuel delivery, enhancing performance with smoother operation and better throttle response compared to carbureted engines. The 2.4-liter engine, part of the high-performance XR series, was designed with a lightweight gear case that improved speed, making it a favorite among racing enthusiasts and setting a benchmark for efficiency and power in the marine industry during that era. Mercury's Optimax series in the 1990s combined two-stroke power with DFI. Outboards also grew more powerful, with 200 horsepower models by the 1990s, competing with inboard engines on offshore fishing boats and pontoons.
The Evinrude E-TEC. It's a dream come true.
Evinrude's response to environmental regulations was transformative with the launch of the E-TEC technology in 2003. This direct-injected two-stroke system reduced emissions by up to 75% compared to traditional two-stroke engines. To understand E-TEC, we can look back to the mid-1990s when Evinrude was facing challenges in the outboard motor market, competing with Yamaha and Mercury. Their two-stroke engines were outdated, with high emissions, and new regulations were becoming stricter. In 1996, Evinrude introduced the Ficht direct injection system, aiming to combine the power and lightweight design of a two-stroke engine with emissions low enough to meet stringent regulations.
Evinrude outboards with Ficht ram injection represent the greatest two-stroke innovation since the invention of the outboard. As we saw in Module 3, conventional two-stroke outboards must get rid of exhaust and bring in a fresh charge of fuel and air every time the piston is down. As a result, the intake and exhaust ports are open at the same time, and some of the incoming air-fuel mix escapes through the exhaust ports without ever being burned. Ficht ram injection solves this problem by distributing the fuel after all the ports are closed. This prevents raw fuel from escaping, which reduces hydrocarbon emissions by up to 88% and increases fuel economy as much as 35%. Because of this, Ficht models offer the performance, lightweight, and quick throttle response of a two-stroke, combined with the fuel economy and low emissions of a four-stroke outboard.
While the concept showed promise, the Ficht system faced significant issues, including overheating, piston failures, oil system problems, and occasional engine breakdowns. These challenges led to numerous warranty claims and class action lawsuits, contributing to the collapse of Outboard Marine Corporation by 2000. However, Bombardier Recreational Products, BRP, known for Sea-Doo and Ski-Doo, acquired the Evinrude brand and re-engineered the Ficht system. In 2003, BRP launched E-TEC, a redesigned two-stroke engine. E-TEC offered improved starting, quieter operation, and up to 75% lower emissions compared to older carbureted models. It featured self-winterizing capabilities, an oil management system, and required no dealer maintenance for 3 years or 300 hours. The engine met and often exceeded environmental standards, outperforming many four-stroke engines. BRP positioned E-TEC as a two-stroke that could compete with four strokes, and it gained recognition from boaters, reviewers, and regulators. By 2007, it was used in various applications, from recreational fishing boats to high-speed police vessels. Evinrude expanded the E-TEC lineup to include 40 to 60 horsepower models for pontoons and family boats, 90 to 130 horsepower models for versatile hulls, and 150 to 250 horsepower high-output models for performance boats. In 2014, BRP introduced the E-TEC G2 series, ranging from 150 to 300 horsepower. These engines featured modern designs, customizable panels, and advanced technologies like 360-degree steering, I-Steer, and I-Trim, with a focus on digital integration and streamlined rigging. However, experiences with E-TEC varied. Some users valued its fuel efficiency, low emissions, strong acceleration, lightweight design, and self-winterizing feature, which simplified off-season storage. Others encountered high parts costs, the need for specialized dealer software for diagnostics, and occasional issues with coils, injectors, or sensors in early models. Dealer support was inconsistent, leading to differing ownership experiences. While E-TEC was technologically advanced, it faced challenges in a market shifting toward four-stroke engines. Competitors like Yamaha, Mercury, and Honda emphasized four strokes as quieter, simpler, and more environmentally friendly, aligning with consumer, government, and marina preferences. Despite E-TEC's competitive emissions, the industry trend favored four strokes. The G2 series, with its complex features, required significant investment in dealer training and tools, which some dealers resisted. BRP remained committed to two-stroke direct injection, choosing not to diversify into four strokes or other engine types. In 2020, supply chain disruptions caused by COVID-19, combined with component shortages and high boat demand, strained Evinrude's production. Competitors with broader product lines and larger dealer networks adapted more effectively. On May 27, 2020, BRP announced the immediate discontinuation of Evinrude Outboard production, ending over a century of the brand's contributions to the industry. The outboard engine's impact is significant. It democratized boating, enabling fishing, water skiing, cruising, and commercial applications in tourism and transportation. The global outboard market was valued at $5.7 billion in 2022, with growth driven by recreational and sustainable boating demand. Major manufacturers, including Mercury, Yamaha, Honda, Suzuki, and BRP, Evinrude's parent company, dominate, while Tohatsu and Chinese brands compete in the small to mid-range segment.
Outboard motoring is a family affair, the attainable dream of life on the open water. You made captains out of kids, Ole. A boy has to grow up to fly a plane or drive a car, but he can go to sea now. The wheel in his hands, his eye on the horizon. The outboard motor will never again be a knuckle-buster, a putt-putt, a gadget. It's the quiet power behind a big idea. The idea that every man may enjoy the pleasures of life afloat. It's the membership card in the all-American, everybody welcome, all hands eligible, no gold braid yacht club.